God bless you, trigonometry students. This is a brief, I think it will be a brief practice test for you before your test coming up tomorrow. I'm sure some of you will be able to see it, some of you will not. But I'm confident that God will use it to help you and to help me also to instruct you in the way which will bring you to your maximum potential in Christ. So let's go ahead and do a few of these. I won't be able to do them all, but I've checked off a few which I think will be useful for you. Of course, the first one is going to be among those, and that one will be write a verse which portrays God's passion for what is right, even for righteous triangles. We've been working with these, and this verse is from Psalm 11, verse 7, and the first word is for, and I forgot this when I first shared it with you, for the Lord is righteous. He loves righteousness. His countenance is upon the upright. His countenance is upon the upright. It's such a wonderful thing to remember. Rehearse it with me a couple of times. For the Lord is righteous. He loves righteousness. His countenance is upon the upright. Again, for the Lord is righteous. He loves righteousness. His countenance is upon the upright. These I will not do because I know you know the conversion going from degrees to radians is just times pi over 180. So I'm sure that will be easy enough for you. Also going from radians to degrees, again, you just multiply by 180 over pi. If you're going to degrees, the 180 is on top. If you're going to radians, the pi is on top. How about number 4? Number 4, we have find the distance s. And this is what we're finding right here. This distance circle a distance s like that. Kind of like a runner who's running a part of an athletic track. It reminds me of seeing the 200, which is a part of the track, usually a little bit more than that. But that's what we're looking for, the distance s. Moved by the second hand of a clock, and it rotates through an angle of 210 degrees. So this angle here, called the central angle, would be that 210 degrees, something like that. That is your theta, and the formula S equals theta R. And who remembers what I said about theta? Theta has to be in radians. So let's go ahead quickly before we forget. Theta, it's got to be 210. Converting to radians, we do pi over 180. Divide top and bottom by 10. Divide top and bottom by 3. 3 goes into 18.6. So we have 7 pi over 6. That's in radians. And now S, the distance we need, is going to be 7 pi over 6 times the radius, and they tell us here that the radius is 8 inches. And since radians have no dimension, our final answer will be in inches. Alright, so that's what we have. If I've got time, I'll come back and just work this out, but just have to multiply 7 by pi by 8, then divide by 6, and the 10th place, you're going to round it to, so that your answer is one number after the decimal. It could be something like 29.2, I think that's what it comes to be, or 35.2. Anyway, one number after the decimal. Okay? Let's look at the other page. On this page it says here, this one is similar, just to find the theta in this one using the same formula, S equals theta R. In this one, it says state the quadrant in which each of the angles, each of the angles below, I should say, is located or found. So this one, and it says do this without converting radians to degrees. So as we have 5 pi by 6, notice that this is almost 6 pi over 6. And 6 pi over 6, when you cancel the 6's, would be pi. So if we start here at our 0 reference in measuring angles, and we go all the way to almost pi, we'd be there. It's not pi or 6 pi over 6, it would be somewhere here. So this would be our second quadrant, quadrant 1, quadrant 2. So that's without using degrees. How about this one, negative pi over 4? Here, negative is going to go in the opposite direction. If we go all the way here, this is negative pi over 2. That's half a pi. We're not going that far. We're going to take it to about midway right here, which is negative pi over 4. That's going to be in the fourth quadrant, first, second, third, fourth. Okay? No, you won't have any troubles with that in degrees. So let's go forward. On this page, I think you'll be all set on this page. Or would you? I trust that you would. Let's go forward. How about this page? Use cofunctions to write the trig function specified below. So, with the cofunction sine is going to be the sine of any angle is going to be the same as, let's say, sine of theta, going to be the same as sine 90, sorry, cosine. Let me take that out. It should be cosine 90 minus theta. Theta is any angle. Now, this is degrees, if your angle is given in degrees, but if your angle is given in radians, then you would do, instead of 90, which is here, you would do pi by 2, and we're going to do one like that. So for this, your answer would be the cosine of 90 minus 30. And so you would report the cosine of 60. Right? Tan goes with cotangent, and cosecant goes with secant. Okay? So this one would be cotangent of 90 take away 43. That's in degrees. This would be the cotangent of 47 degrees. And then this one now is one which could maybe give some people problems, but it should be that cosecant goes with secant. And since it's given in radians, pi over 6, then we'll use not 90, but we'll use pi over 2. Pi over 2 for 90 minus pi over 6. Okay, let's work that out. We have pi over 6, sorry, pi over 2 minus pi over 6. Our LCD is going to be 12. Made the same mistake in reviewing. It's going to be 6 minus 6. So times 3 here would give me 6. So this is times 3. This is 3 pi. And times 1 here would give me 6. So times 1. Okay. So this leads me to 3 pi minus pi is going to be 2 pi over 6. And when I divide top and bottom by 2, I end up with secant of pi over 3. That's that one. Alright. These I trust you're at peace with. Determine which quadrant each angle is located. I'm very confident you know that. Let's see what else we've got. Well, these two here, reference angles. Let's take a look at these two reference angles. It says find the reference angle. And I told you that reference angle is always in reference to the x-axis. So it's going to be positive x-axis or negative. Positive or negative. Let's take a look at this one. Negative 95 degrees. Let me set up a coordinate plane here. Negative 95 would take me here. Negative 90 and 5 would be here. I stop. This is negative 95. So I draw a ray to this position right here. And my reference angle would be theta right here. And this is going to be the angle which would take me from 95, negative 95 to 180. It's going to be the positive angle. So the reference angle here will be 180. Take away 95. Again, it's going to be the positive angle. Borrow. Can take away 5 is 5. Borrow. 17 take away 9 is 8. So the reference angle is not negative now, but the positive or absolute value of the angle that this ray makes with the x-axis. That's the reference angle. Let's take this one here in radians. This is 3 pi by 4, 3/4 pi. So if I go this way, you know this would be a half pi. And right here, right in the middle, would be 3/4 pi. 3/4 pi, not 3/2, but 3/4 pi, about right here. And if you keep going, that would be pi. So this is a quarter. The rest of it that would lead me to 180 would be a quarter pi. Again, half, 3/4, and then to get to pi itself, I'm missing a quarter here. So this reference angle here would be 1/4 pi, or pi over 4. Again, that's the angle it makes with the x-axis. This is the negative x-axis this time. So much for that. Let's find the value of each of the quadrantal angles or write undefined. And please